are at a site that we're hoping to use for part of the master's course, and the fantastic thing about this site, apart from the views, that we've got, I think, 3 stages of permafrost here. So we've got intact permafrost with pulsars that sort of protrude up out of the ground, and then we've got different stages where partially thawed permafrost, where the ice is starting to melt and the landscape changes, the vegetation changes, and then the final end, which is kind of fully thawed permafrost. You can't see any. So we're going to try and explore permafrost with this very complicated permafrost probe, and we're going to go out and try and explore, see how deep the permafrost in these different zones are, and then we're going to try and set up Northumbria's first field station in Abisko. So what's great about a location like this is you've only got a shallow surface, so we can dig down. This is the active layer, this top part. Yeah, and there we go. You can touch the permafrost underneath. Solid ice down here, and you can hear there's solid ground underneath.
Okay, so lakes are very affected by the amount of organic matter within them. And in this area of the Arctic that's changing very rapidly, you've got frozen peat that's, as it thaws, all that carbon is getting down and being transported into these lakes. And one thing that's really interesting to look at is how that has changed through time. And one way we can do that is to reconstruct that through taking a sediment core in the lake itself. And this type of equipment you could use for that, or there's other types of core you can use as well. This one here will just demonstrate. This is a Russian core, normally used on peaty environments like this. So to put it in the ground, you set it like that. And it's hard work. Okay, Chris?
Right, ready?
Yep. And pull it up. And those sediments will contain a record through time, so we can analyse various different proxies contained within them to reconstruct that environmental change. Okay, so this is a sediment core we've managed to collect from the bottom of this lake. So sedimentation rates in Arctic lakes are quite low, so this probably represents quite a large period of time, a good few hundred years. And what we're going to do is take this out, and then we could extrude it, slice it up into little bits, and then measure the amount of carbon and the amount of organic matter in that core and the changes.
I think the real value of this Absiko field course is that obviously it's a fantastic, beautiful place to be. The field station's incredible, but the skills and techniques about how you monitor, how you can reconstruct the past, skills that you're learning here can be used in all sorts of different other places, so not just in the Arctic, but in industry, consultancy, so on.
So I think this course really consolidates what you will have learned throughout the rest of the year, and gives you the opportunity to apply all these techniques in this really fantastic setting.